Is it recording? Wow, okay. Okay. So you see, this one is multiplexer. You can see you have two inputs. Okay, two, and you have one. Okay, so you have two n. Okay, and then what? In order to have two, you will require 2 to power of 1 equals to 2, right? So this one will be your data selector, only one, and this will be your combinational of inputs. So if you have four inputs means 2 to the power of what is equal to 4, means 2 to the power of 2. So you would have data selector equals to 2 here. Okay. So for this multiplexer, for example, okay, you have okay, wait. Okay. So means that here, in order to have an output of y, you would require 3 combinational inputs. Okay. So means you have S, I0 and I1. Okay. So if the selector is 0, okay, means it will choose I0 as its output. Okay. If S is equals to 1, it will choose I1 to be its output. Okay. Then this one is just a combinational because 2 to power of 3. So you have 8 possible combination. Okay. So first look at this 0, 0, 0. Okay. So at this 0, 0, 0, it will actually, when the data set is 0, it will follow I0. Okay. So that's why it's always the same with I0 for the Y. Okay. So next is if it's 1, it will choose the I1. Okay, that's why you can see it is always the same here. Okay. Then after that, you can further simplify the circuits, okay, the truth table, into this smaller version where whenever whatever selector that we have, possible combination of 0 and 1, and then the output will be following I0 or I1. Okay, and then you can make an equivalent circuit. Okay, equivalent circuits. Okay, much simpler. So for example, S. Okay, let's say you have this one is so let's say you have your S. Okay, data selector. Then you have a NOT gate. Okay, and let's say you want to do SOP, sum of products. Okay, sum of products. So you will having a OR here. Okay, because it's sum of products. Then you can see that actually the first function, it will require S equals to 0 and Y equals to I0. Okay, S equals to 0 and Y equals to 0. So you see first is like this. Okay, for the first combination. Okay, and then you have I0. Then you have an N. Okay, so the second one is that you need S equals to 1 means this one, and Y with I1. So you have I1. Okay, so you have I1 here. And it is sum of products, so that's why like this. Okay, so quite simple actually. This one will be extended to much more bigger multiplexer. Let's say you have saya dah record kan? Dah record kan? Okay, dah record. Okay, baru baca message Ayu. Okay, so this can be translated to much bigger multiplexer, for example 4 to 2 multiplexer. Okay, the way that we name the multiplexer, this one is one of the way of the naming 4 to 2. Then the other one of the other namings, okay, if you go to the module page, okay, those that have the module, you may refer to your module page number. Where is the page? Where is the page? Multiplex. Okay, so you can refer to page number 101, 101. Okay, there is 8.1 multiplexer. Okay, and then you can see at the second paragraph, the way out, the way we naming it. Okay, so first is that we can have the naming is 2 to 1 multiplexer, and the next naming is one out of 2 multiplexer. So the way it's named, the way we name it, make sure you know how to differentiate. For example, this one is 4 to 2 multiplexer, means this one is your input and this one is your output. If the other name, the way of naming is, for example, 1 out of 2 marks. Okay, means that this one will be your output. Okay, this one is your output. Sorry, this one will be your output, and this one will be your input. Okay, the way of naming, this one is 4 to 2 and 1 out of 2. Okay, 4 to 2 marks or 2 out of 4 marks. Okay, so it's the same, then just the way of we naming it. Okay, so then you can see from the for the module. Okay, then what is this? Okay, so this one is further extend to the 4 to 1 multiplexer if we have much bigger multiplexer. Okay, and also 8.8 to 1 multiplexer or 1 out of 8 multiplexer. Okay, the way of naming. Okay, you can have the other naming is, for example, this one. 1 out of 8 multiplexer. Okay, like this. Okay, so make sure you know. Okay, so for the 8, nothing different. It's just expanded version. So this one is to have 8 combinational inputs. Okay, 2 to the power of what? Means 2 to the power of 3. So we have 3 data selector. Okay, and for example, if it's 001, it will choose I1. Okay, 001, it will choose I1. Okay. So this one is just the extended version. Okay, please ask if you don't understand, because it's actually been elaborated in detail in my videos that I ask you to watch. Okay, then I also explain about this. Okay, so the waveform selector. Okay, one of the application of the multiplexer is in telecommunication, where we actually can choose the frequency of the signal that we want, okay, to pass through. Okay, so if you see this one is 1 kilohertz, and we go to much smaller frequency. Okay, for example, this one is 1 to 5 gigahertz. Then you go to much higher, 250, and so on. So its frequency means the number of complete cycle in a given of duration. So if you notice that the higher the frequency, the more complete cycle that you have. For example, this one is 1 complete cycle, but for a given time you only have 1 complete cycle. For 250 you have 2 complete cycle. For 500 you have 4 complete cycle, and so on. Okay, so the higher the frequency, the bigger the I mean not bigger, the more we have complete cycle. Okay, so you see, if you put 0 1, for example, here, so the Y output we choose 500 hertz. Okay, actually this is just the same as what in the slide, 2021. Okay, then the next is if we want to have, okay, for example, in a situation where we have many outputs. Okay, however, we don't have much we don't have bigger multiplexer, so we can actually cascade. We can cascade several smaller multiplexer to achieve to achieve more outputs. Okay. So you see here, okay, we have 4 multiplexer, which is 4 multiplexer of 2 to 1 or 1 out of 2. Okay. You see S here is data selector, so it's still one data selector because it's using still using 2 to 1 matrices. So 2 to the power of 1 is equals to 2. Okay. So 2 combinational input and 1 data selector. Okay. So whenever S is turned to 0, okay, it will choose A0, A1, A2 and A3. So it will goes to here. There is error here. This one should be 4. 4, 4. Uh, no, this one should be 4. This one also should be 4. It means four inputs. Okay. Oh my god. Wait. You see, this one very disturbing. I cannot close this one. This one. The moment I share the screen, this one disturbing. Can you see how inconvenient it is? Okay. So this one is 4. I'm correcting the error now in the slide. Okay. Then this one also 4. Okay. So means you have four possible inputs, A0, A1, A2, A3, and another possible 4 inputs of B. Okay, then you have 4 possible output lah, which is Y0, Y1, Y2, Y3. So this is the way we simplify our representation. Okay. Okay. So rapid implementations of logic function. Okay, so this one, so you see smaller m here. What does it mean? What does it mean? Can you guys tell me what does it mean by smaller m here? In the Webex chat, what does it mean by this? Okay, so it is terus caps lock Aina. Ya, saya nampak lah kata minta tu. Okay. So is M mean it is mean term. So means sum of products. Okay, sum of product mean sum of product we will refer to what? Output function 0 or 1 for sum of product. We refer to output 0 or 1. Can you guys respond? Okay. For sum of product, we refer to output of 1. Okay. So that's why 0, 5, 6 is actually the one that having answer of 1. So 0, 5, and 6. Okay. So the rest, of course, 0. It's like complement. Okay. So means that if, for example, if we were to write this, okay, let's say we can have another function here. Okay. The pi. Insert symbol. No. Hmm, Never mind. Wait. Okay, for example, if we want to have to write in terms of different kinds of representation, different ways. Okay, so we can write this one is also in terms of POS. Okay, POS big M. So it's 1, 2, 3, 4, and 7. Okay. So this is how you do it. Okay, what is this? Okay, and this is data selector. Okay, because we have 8 inputs, 2 to the power of what? N. So we have 8 inputs, so n is equals to 3. So that's why you have data selector 3. And always because of this is a multiplexer, you have one output come out of this. Okay. Next, what is this? Uh, huh? Wait, okay. Pening saya tengoknya. Okay. So this is rapid implementation. Then you can have okay. This one is actually if you want to do simplification of your circuits. Simplification. Okay. So this one you need to learn through practice. Okay. Maybe I can show you some general, but you need to do practice because problems can be many, right? Many types of problem that you can solve. It can be asked. Then you need to do practice in order to use to better solve this kind of question. Okay. Okay, this one is actually to simplify instead of having too many A, B, C, D. Okay, so you try to relate. Okay, you try to relate. Okay, first, you try to relate with whatever that is actually have direct connection. For example, here is all of your outputs. Okay, this is all of your outputs. Can I make it bigger? Okay. Okay, this is all of your outputs. Okay, and you try to compare with one of the inputs, for example. Okay, so we're comparing with, for example, for this stage. Okay, because okay, if you see this one is 1 2 1 2 3 4. Okay, there is 1 2 3 4 inputs. Okay, we try to see what is the suitable inputs. Okay, so if you see this one is 4, means you have 2 to the power of 4 is equals to 16. Okay, means you have 16 data and 4 selected input initially, but then you try to simplify it to be, for example, to now you try to simplify 2 to the power of 3 equals to 8. Okay, means you have 8 combinational input, then you have 3 data selector. But in order to do that, you need to do some simplification first. Okay, so for example here, okay, you can see because we want to make it as 2 power 3 into 8 input, so you need to divide it to 8 lah. Okay, okay, to 8 because from 16 go down to 8. Then you see, you try to see for this first thing, first one is always 0. It's always 0. So that's why it is 0 here. You see? Okay. Next, you can see it's always 1 here. Okay, always 1. So it is 1. Okay, 1. This one, maybe you say, okay, understand. Okay, you understand, but you need to try first. Otherwise, if you see the question, you cannot do. Okay, understand, yes, but you need to practice. Then after that, you see, we try to evaluate the third one. Okay, you see, it's always follow the same with what? It's always consistent with D. So, at the third one, it is actually D. Okay, it's actually D. And this one, you can see it is the inverse. Okay, always complementary with D. So this one is a D bar. Okay. And then you see this one is also always inverse. So it's D bar. And this one is always inverse. So it is a D bar. Okay. And this one is always the same. So it is actually D. Okay. And this one is always 0. So it's 0. That's why we have this. Okay. Understand? This one you try to simplify from this one to this one. Otherwise, we need a bigger multiplexer. You guys understand? Okay? Understand? This one you need to do practice. Huh? Understand? I'm not sure it's covered in my video, but but it's maybe it's covered by second part of my video lah that I didn't ask you to watch. But you will watch later lah. Okay? So this one is quite straightforward, but you need to practice because the problem can be many. We can ask you many things. Okay? So this is again, okay, for example, if you want to implement 4 to 1 marks, okay, let's say again that I told you, we have a lot of, let's say we want to realize a bigger marks operation initially. However, we only have a smaller multiplexer. It's okay, we still can able to go around with it, okay. So here, okay, we implement 4 to 1 marks, okay, 4 input to 1 output marks using 2 input to 1 output marks. So you instead of using instead of needing 4 to 1 marks, you need smaller one but 3 multiplexer, which is 2 to 1. So here, okay, so you can see this one is okay, so this is selector. Okay, so you have 2 selector, S0 and S1. So you have 0 0 0 1 1 0 1 1. Okay, and then you have the possible output. Okay, the possible output. So you see the marks here, the multiplexer. Okay, this one, for example, if we choose 0, if we choose 0, S1 equals to 0. If S1 is equals to 0, it is always choose this one as 1 here, and it always choose 1 here, and it's always choose sorry sorry, if we look at this one, we look at this first, S0 S1. So this one is 0, this one is 0. Okay, so it will choose 1 here, going to out here S1, and then it going to choose S1 here. Okay, if it's 0, it will choose 0. So 0 and 1. Okay, 1 go to here and 0 go to here. And then S0 is actually 0. So that's why we choose, it will choose 1 here. Okay, S0, it will choose this one. So that's why you have answer of 1. Okay, I think this one is quite straightforward. Let me know if you don't understand, because this one is actually, we try to minimize our multiplexer operation from a bigger multiplexer. We use a smaller multiplexer. In case, like for example, this one can be happen in your real life as engineer, for example. Instead of using one big wood, you can still use 3 smaller woods in order to achieve the same length, for example. Okay. So this one is implementing 8 to 1 marks using 4 to using 4 1 and 2 to 1 marks. Okay. This one, if you see for this 4 1 marks, okay, sorry, implementing 8 1 marks means you have 8 inputs, okay, which is I0 until I7, okay, and then you have 1 output, okay, and because it is 8 inputs, so you will have 2 to the power of 3 equals to 8. You will have 3 data selector. Then it split the data selector into S2, S0 and S1. Okay, so please do this at home. Please do this at home and try, okay, to understand. Okay, because this is just an extension, okay, example of how they do it. Okay, and this much smaller and more number of multiplexer is actually equivalent to one bigger multiplexer, which is this. Okay, Okay, demultiplexer I won't touch today. Demultiplexer because we will touch it after. Okay, and my video only showing the videos. The videos did I ask you to watch? Okay, you see. Wait, this one until going up. Okay, you see how annoying Webex is. Okay. Hmm. I think the video that I asked you to watch doesn't have right, doesn't have the multiplexer, okay, the one that I asked you to watch, okay, because I watch also, I watch my own video, so that's why it's more even important that you watch it, okay. For me, I watch it to as a refresh, but for you, it will help you in your understanding digital IC. Is it digital IC?
Hey, it's Marie. So look,
Okay.
I know that you want to grow your business, and I want to remind you.
Oh no, not this one. The one that I asked you to watch didn't cover the multiplexer. Am I correct? Am I correct? It's only cover multiplexer, right? Um, Playlist. Hmm, chapter 5. Combinational MSI, okay? So I only ask you to watch this, okay? Which is only cover multiplexer. Am I correct? Yeah, still multiplexer. So please watch, because it's I already explained in detail, 40-minute video, and I also ask you to watch the other video. Okay, there's two. So today is actually basically only that. Okay, so I won't touch about the multiplexer. Coming from your semester Smith and break, we will cover the multiplexer and finish. Okay. Actually, with that, it's already finished whatever we want to do today. Okay. Um, and I dismiss you guys earlier. Just a very uh very short lah. Okay. Because this one actually we are ahead of the schedule lah. Okay. So the more reason for you to have more exercise lah. Okay. So I will share to you the. Wait, I'm trying to check my. Hopefully it will help you for your test one lah. Okay. So wait, I'm trying to see. Oh. One, two. Okay, so you see here, maybe I will give this exercise. Uh, you want or not this exercise, or you don't want? Hmm. So this is exercise for you to practice. You want or not? Or maybe you will complain. Maybe you complain. Raimi give too many exercise. Dr. Raimi give too many exercise. I never work like this for any other course. Oh my god. Then what you want? No, don't want exercise but getting A. Okay. So okay. So I will give it to you. Okay. You guys can do it during the midset break. Is it okay? Okay. You see, it's 4 pages. A lot of things here. Okay. So we see, for example, determine whether the Boolean equation are true or otherwise. Each letter represent a variable. Okay, and then obtain the truth table. Okay, I think this is good. Okay, okay. Read the following paragraph and fill in the blank with suitable words from the given list. Okay, For example, digital technique and system have the advantage of being relatively much easier to design and having higher what? Okay. So you need to guess, not guess, to see which the accurate words for that. Programmability, noise immunity, easier storage of two. Okay. Two, information. Is there any information here? Data lah, data, still the same, data. Okay. Easier storage of data or information. Okay. And ease of representation in integrated form, leading to ability of more complex function in the smaller size. The real world, however, is analog. Most physical quantities, position, velocity, and then whatever here. Okay. So, okay. So, I can see Joey 1, Dayana 1, Nurul Aina 1, Nurul Najwa 1, Ayu 1. The other don't want. Okay, no problem. I give only those that want to learn. Okay. So, on... okay. When I said it, suddenly many respond. Okay. When I say like that, suddenly all people want. Okay, no problem. I will give. Okay, so please practice it. Okay, I will share. Okay, wait. Better I do now before I forget. Better I do now. So we finish our recording. Our lecture today only. Okay, because it's only on multiple.